Hello everyone and welcome back. This week we're going to focus all of our attention on the creation of our UV maps. Over the last 3 weeks we spent a significant amount of time talking about the modeling stage of our little treasure chest. Well, now it's time to advance into the texturing stage, and this week's entire conversation is going to revolve around the creation and the strategy of creating UV maps. So here's geometrically where we left off, just a very fun little treasure chest. Last week we spent some time talking about how to make some goblets, and hopefully you've made some fun treasure to go on the inside of your treasure chest. Well, let's start talking about UVs. Now, the UV mapping workflow inside of Modo begins and ends inside of our UV tab here at the top of the screen. Now, depending on which layout you're working in, you can either find the UV tab here if you're working in the tabbed layout, but if you're not working in the tab layout and you're using the UV switcher, it is this one right here, the UV edit workflow. There we go. So this is our new home away from home. And as you can see, the interface has been drawn just a little bit differently, and all of the UV mapping tools have been brought to the surface. On the left-hand side of our interface, all of our modeling tools have been replaced with all of our UV mapping tools. But I think really importantly, note that there's still access to all of our modeling tools in this little popover. Hitting the F2 key will bring open this guy, or clicking on the little button. We're just going to get rid of that for the time being. Now, the big difference between the modeling environment and the UV mapping environment, of course, is this new area in here, this new layout, this new viewport, because it's giving us access to our UV grid. So what is UV mapping? A lot of folks get a little confused as to what a UV map is and the purpose of a UV map. Well, let's talk about this conceptually here for a moment. I'm going to go ahead and grab the little medallion at the front of my treasure chest and just hide it and turn off the bottom of my scene. And here is a very unique piece of geometry. I want to accurately place texture information on the front of my little star medallion here. UV maps give us the ability to very quickly and very accurately place texture information. We're no longer using general projection types to get information placed on these polygons. We're using UV maps, so they're accurate. They give us a little bit of accuracy. Actually, they give us a tremendous amount of accuracy. Okay. If you think about what a UV map is, it is basically a two-dimensional representation of three-dimensional geometry. Another way of approaching it is think of it like this. It's the pattern to a dress. We're kind of working in reverse here. If you think about the way a seamstress goes ahead and creates a piece of clothing, they're going to start with two-dimensional bats of fabric, right? They're going to have a pattern. They're going to trace the pattern on their fabric. Then they're going to use some scissors or fancy machinery to cut shapes out of that fabric, and then eventually sew those individual pieces of fabric into what will ultimately turn into a three-dimensional piece of clothing, and three-dimensional being, with a person inside of it. That two-dimensional form takes on a three-dimensional shape. We're working in the opposite direction. We already have our three-dimensional model, and now we need to create the pattern for that three-dimensional model before we can start painting on it. Because UV maps, they give us the ability to take all of our assets, all of our models over into a third-party painting application like Mari, or maybe even like ZBrush, or maybe even like Photoshop. It gives us control over where this two-dimensional image information is going to be placed on our model. Okay, it's not magical, but it is laborious. Oftentimes, you'll spend more effort and more time making your UVs than you will making the darn model itself. So just kind of strap in. I tell my folks all the time, at this stage, there's a lot of repetition, but the end product is so much more stronger because we get to accurately place texture information. Because think about it, at the texturing stage, we're taking two-dimensional photographs, right? And we're wrapping them, we're placing them on three-dimensional geometry. The UV maps are going to give us the best result. And they're going to give us the most control and the most accuracy of the placement of those images. So let's jump in and start talking about how we can make some UV maps here. There are a number of tools that we can use to get UV maps. And as I mentioned before, what we're ultimately trying to capture here is two-dimensional information of our three-dimensional little polygons here. And let me turn my wireframes on. And to make it a little bit easier for y'all at home to see, I'm going to return to my shader tree and temporarily deactivate all my matte cap shaders by grabbing my base shader and just dragging it to the top. And now they're all off. Okay. The shader tree evaluates from the bottom up towards the top. So in actuality, it's looking at the base material. It's looking at these three material groups, and then once it hits the base shader, it's applying all that information to everything that's below it. So it's kind of overwriting all the shaders that are underneath it. Okay. Let me just turn those off just to make it a little bit more computational easy for my computer here. Okay, I've also gone ahead and unsubdivided my mesh. That's the first trick that I really would love to enforce and suggest as you go through this whole stage. Don't try to do any of your UV mapping on subdivision surface modeling. You're going to get confused. The edge selection process is going to be kind of unknown. It's the path of least resistance is to unsubdivide everything inside your scene. So let's go ahead and do it. This first one's going to be relatively easy. We're going to use a tool called the Unwrap tool, and I'm a big fan of the Unwrap tool. Now, conceptually, what the Unwrap tool is going to do is that it's going to use a whole series of edge selections as kind of a surgeon's scalpel, if you will, and we're going to be slicing our mesh conceptually now, not physically. We're going to be conceptually slicing our mesh along these edge selections. Now, from these edge selections, the computer is going to start to warp and bend certain polygons around that border. Let me show you what I'm talking about here. So what I want to do is I want to try to have this front of my star be as complete as I possibly can. The one thing that texture artists are always fighting against are seams. It's kind of a necessary evil. You can never completely eliminate texture seams within inside of any asset, but we want to try to mitigate and reduce their apparent nature as much as we can. It's kind of a big deal. So let me just grow my selection here a little bit. So ideally, I would really like to not see a whole lot of seams in here, and I think the selection that I have in front of me on the screen, which is basically everything except the back, is a good representation of what my brain is telling me the end result should be. I want all of this to be one UV island so that when I paint it, I'm not seeing any very noticeable seams along these edges in here or these plane changes in here. I'm seeing as consistent of a shape as I can. So we have to think strategically about this. Where do I want my seams to show up? Well, I always tell folks, try to place your seams in the areas that the audience is least likely to see them. In our case, this back here, this back piece, that's going to be rear facing. The audience really isn't going to get an opportunity to see this. So that's a great place to naturally put a seam. Now, in order to get the type of wrap that I'm after for all of these areas in here, I'm going to have to infuse a couple other seams. This is going to be a multi-stage process, and as you go through it, hopefully you'll start to understand some of the nuance and the strategy behind unwrapping this object. So let's do it initially, kind of really quickly, without very many seams and without very many edge selections, and let's just see what we get. So I've gone in, I've selected that back edge loop for my entire piece here, and we're going to use that as the seam, major seam. I'll put another one here for the opening. Wonderful. Let's use that as a starting point. And now what we're going to do is that we're going to return over here into our UV toolbar, and I'm going to choose the Unwrap tool, which is the third one from the top. There it is right there, bam. And now down here at the bottom, we have a number of tools that are important to look at. Specifically, the initial projection type. It's set to planar. So you want to analyze the type of surface that you're working with, its basic shape, and ensure that its corresponding initial projection type matches as closely as you can. There's some basic ones in here, but this is definitely something you'll want to experiment with. My star is relatively flat, so I'm going to choose planar. And then, of course, the projection axis is also really important. Now, for my little star, I want to project this thing down what's going to be the z-axis, so I'll just go ahead and start that off. And now, the way the Unwrap tool works is that we click inside of the positive UV grid. So we'll click once, and you can see what we get. Now, the magic of the Unwrap tool is that it's based off of an algorithm, and we get to continuously add new iterations of that algorithm on our mesh by increasing this value right here. So you can absolutely slide it like that. But the guys down at the Foundry have done us a solid, right? If we keep our mouse cursor in the UV grid and just continue to left click, you can see that that iteration value continues to go up and up and up. Okay, so I've dropped my tool, and you can see what we have now. Welcome to UV mapping. Now that we have some UV islands to play with, we can start talking about some of the specifics of working inside this very kind of strange environment. So each one of these solid kind of whitish gray shapes is called a UV island, and each individual polygon within the island is represented, or is called a UV. The total sum of all of our UVs is called a UV map. To access all of our UV maps inside of Modo, it's really easy, and I love the way they communicate all this information to us. We're going to return to the right-hand portion of the interface, we've been hanging out in the Properties tab for some time. But if you keep going down, we have this Lists tab, and there it is right there. And you can see that we have a section of all the different maps that are currently available and working inside of our scene. And here we go. Here's ours. It's called UV Map. At the moment, I have 2 UV maps active inside of my scene, one called Texture and one called Treasure Chest. Now, the default name for all UV maps is going to be Texture, and Modo is going to try to do its best to create a whole bunch of default UVs for us, and I would recommend immediately just deleting or clearing those UVs from the default texture map. They're always going to be incorrect. They're never good. Actually, I kind of wish they would just turn that feature off, because it adds a couple extra steps at the beginning of each texturing stage just to remove all of the pre-built UVs. They're quite poor. So the easy way of removing them globally is just to right-click on the map and choose either Delete, which will delete the entire map, or Clear, which will delete all the UV islands and UVs inside of the map. No, I'm not going to do either of those, because I want to keep these 2 UV islands on my scene to continue talking about the role of their role inside of the larger texturing workflow. Now, notice where the computer automatically placed these 2 UV islands. If we zoom out a little bit and look at the totality of our grid actually has 4 basic quadrants. And if you go back to 10th grade geometry, you remember that we spent a whole significant amount of time in 10th grade geometry plotting points along a 2D Cartesian grid. And fundamentally, that's exactly what we're doing here. We have a whole series of values. We have the U-axis, which is the left to right, and then we have the V-axis, the green one, which is up and down. The computer is always going to place all of our UV islands automatically for us inside the positive quadrant of our UV grid, which is the upper right-hand quadrant. If you go way back to 10th grade geometry, this positive quadrant, this area right in here, is the only part inside of our 2D Cartesian grid where we have positive values for both axes, in our case, the U and the V. So these are the only grid squares that have positive U, and positive V values. Down here, we'd have positive U, but negative V, negative U, and then we'd have negative U, positive V, or over on this one over here. So the positive UV quadrant is where we're going to be doing the lion's share of our work. Now, this doesn't mean we can't put things outside of the positive quadrant, but this is the default location that Modo is automatically going to generate our UVs and UV islands to. So just be aware of that. Okay. So let's start doing some work here and start looking at how we can use these UVs to help us get the best texture possible for us. Now, the moment that you start creating UVs, I recommend that you add in a checker material or a checker image into the scene here. And really, what I'm looking for you guys to add is an image that looks somewhat like this. Now, I'm going to go into my mesh preset library, or excuse me, my preset library by hitting the F6 key on my keyboard. It's going to bring up my preset library, and I'm going to go into my assets directory. Here is images, and then inside this long tree view, here's a section called UV, and here are a number of really fantastic checker patterns that I would recommend and encourage you guys to incorporate into your UV pipeline. I'm going to use this one, the rainbow one, just because it's really fun and it's easy to see all the different changes in values. So I'm going to add that into my scene just by double-clicking on it. It automatically is added to the clip viewer, and if we return to the shader tree, it's not in there yet, so we want to make sure that we start getting this image into our scene. Now, the reason why it's showing up, or this checker pattern is showing up inside of our UV grid, is because it is selected over here inside of our clip browser. If I hold down the control key, or come on, whoops, there we go. If I hold down the control key and click on the image, you can see that it disappears from this environment as well. Which brings us to some visibility options inside of our UV workspace. Some people always like having that image behind no matter what is being displayed. Some folks don't like any image behind. And managing what is selected in the clip browser can turn into a little bit of a nightmare. So here's a great suggestion. At the top of our UV grid, we have this little gear icon, which will give us a whole series of options for this part of our interface. And down here at the bottom, check it out. There's an option called Show Image, so we can turn that on and off. So that's definitely something that you'll want to take a look at. In addition, the Visibility tab over here is going to give us some options that I think are really, really, really important for you to look at. specifically show inactive UVs. Turn this off for the most part. It's going to help you understand the UVs that you're currently working on and the role of those UVs inside the map you're currently working on. If show inactive UVs are on, it's going to show in a black wireframe kind of form every single UV map for your entire project, because every item is going to have multiple UVs. And as an illustration of this, I'm going to go over to my bottom. I'll create a new UV map, and let me just very quickly create some UVs. Okay, so I just made a UVs of that front panel. If I return back to my top value, okay, and let's put show inactive UVs on. If I select, oops, sorry, my background item was off. Let me turn show inactive UVs on. There we go. That's what I was after. So check it out. So I have right now in the background of my positive UV quadrant, I'm seeing the UV maps or all the inactive UVs for the bottom mesh object. And that can get very, very, very confusing. And it can start to cloud your entire workflow. So I recommend turning this off, show inactive UVs. That way it's just very clear and very concise, and you don't have to worry about managing all that other stuff that's happening inside of your scene. All right. Let's get back to work here. Now that we have that checker pattern imported into Modo, let's begin to work with it in a meaningful capacity here inside of Modo, okay? Inside of my shader tree, I'm going to do add layer, image map, and we don't need to load an image. We're going to use the clip browser, and we're just going to grab that guy, okay? And you can see that since it's at the top of my shader tree and outside of every single one of these material groups, it's being applied to everything, which is precisely what we're after. Okay, so let's do some triple checking here. Now, currently, I'm on my top mesh item, and I'm working inside of the texture UV map, and that is just kind of bad naming convention. So let's just name this top UVs. You want to make sure you go in and rename all of your UV maps the moment you create them or the moment you start working with them. Remember, the default name is texture, so if you don't change these, it's going to be very, very difficult to understand which UV map you're selecting inside the texture locator. Let's go back over into our shader tree, and I'm going to select my image, my UV checker pattern up here at the top. Go to the Properties tab, and now we're going to look at the Texture Locator, because this is the thing that we want to triple check. The Texture Locator inside of Modo is wholly responsible for placing two-dimensional textures on three-dimensional polygons. It's the one thing that determines how and where things go. And with it selected, this parameterization section will tell us how this image is being projected onto our model. The default projection type is UV. However, we have kind of a number of the other standard UV options as well. And then we get to select the UVs that we want down here. So I'm using the top UVs, and you can already start to see if everything is named textured, this list is going to turn into a nightmare. Now I can very, very easily go and pick and choose which UV map I want to use. This list is being generated from a scan of every item inside of our mesh or inside of our Luxology scene. Okay, so if you have 40 different mesh items, each with 2 different UV maps, this list is going to be 80 characters long or 80 items long. So I think the naming conventions of our UV maps are critical. Okay, so there it is. That's on top, and that's exactly what I want. So now we're seeing a really good representation of how this 2-dimensional image is being placed on our 3-dimensional model, and everything is looking pretty good for the most part. Now, what we're looking for and why we suggest using a checker pattern is so that we can easily spot distortions. Okay, and let's talk about the size of each one of these UVs in relationship to how this image is being placed on the actual model itself. Okay, and at their current size, it's very difficult, very, very difficult to get a good understanding of how this image is, or if this image is distortion free. So we want to change how often this texture is being placed inside the geometry itself. And there's a couple different ways we can do this. The placement of an image and how often an image is repeated inside of a UV space is directly responsible, or is directly tied to the size of that UV island inside the image map itself. Now, if you look at this checker pattern, you can see that this area right in here is basically dominating what would be maybe like a 4, like a, let's see, what, 1, 2, 3, 4, 5 by 5 square, okay, of these little grids in here, okay, and you can see that we're actually talking about the back here. See how if I roll over CO3 here inside of my UV view, it automatically selects that area inside of the mesh, okay. That's because these over here are the exact same polygons as we have on the right-hand side. These are the two-dimensional versions, okay? And these are the three-dimensional versions, okay? They're the exact same thing. So we have to be careful. We can move, rotate, and scale all of these UVs. It's really easy. Just the traditional move, rotate, and scale tools will work. And as we move them around inside of our UV environment, you can see that we can place that UV on a different part of the texture. The texture itself doesn't move. The islands move with inside the UV. So for example, maybe if this part of the texture had a lovely rusty wood pattern, on it, we could put the back UVs in that area, and it would adopt that part of the texture on that part of the model itself. Okay. The size of these UVs determine how many pixels are going to be used to create the texture in that area. And with my little 5x5 grid here, you can see how many individual checker pattern squares from my image map are being placed on the back. If I increase that size, check it out. Now we're physically getting more pixels inside the back area of my little star here. And what we're able to do is to increase the quality because now of the texture, that is, because now we have physically more space within inside the texture that is being reserved to draw the back of the image. Now this is another one of our grand challenges, is understanding the relationship between the texture itself and the polygons. The more, the larger the UV island is inside of our texture, the more pixels in the actual texture map we're going to have to describe that part of the interface, or excuse me, that part of the model. So, and we want to make sure that all of our UV islands are basically packed at the exact same size relative to each other, okay? That way, no part of the mesh is of higher quality than the other part of the mesh. Because let's say if the back of my little star here was this size, okay, which is pretty gigantic, and the front of my star was this size, my front, I would only have maybe, a 40 by 40 grid of pixels inside of a 1K texture to describe all of the detail on the front, versus this star over here, which would have, maybe, about 700 pixels worth of information to describe the detail. The more pixels we have, the more detail we can place in that area. But we want to make sure that there's a consistent quality level across the entire mesh. We want all of these to be basically of the exact same textile density, as it's called. We want the same ratio of pixels for each one of these areas. Okay, so I'm going to go back in time and hit undo a couple steps here, because the unwrap tool does a really great job of preserving the textile density. And let me go back in time. Sorry, whenever you click on something, it automatically saves it in your undo queue. And eventually I get there. There we go. Okay. So now, if you look at the relative size of each one of the squares in the texture on one UV island to another, I would say they are very, very close in size. And so this is one of the areas that we want to first kind of spend some time on, is ensuring that the size of each one of our checker patterns is roughly the same. That way, when we send this over to Mari or Photoshop, we know and understand that there's going to be a consistent quality level across the entire area. No one part is going to be of higher quality than the other. So there's two different ways that we can increase and decrease the size of our checker pattern on the model itself. And this is something that I do when working with these really big checkers on the texture itself. It's kind of hard to see and understand, especially as we wrap around the model, how well of a job we're doing. So let me show you one other thing here. With my image selected, I can go down to my Properties tab, and once again, I'm going to go back to my Texture Locator section, and we have these two wonderful values down here, horizontal and vertical wrap. And right now, we're basically stamping. We're repeating our single UV checker pattern texture one time inside of the positive UV quadrant. Now, if I was to up this to like 5x5, now the computer is going to tile that exact same checker pattern in the positive UV quadrant 5 times along the U and then 5 times along the V. Now, a lot of folks, and this is the result that we get, a lot of folks, they get confused because they don't actually see the tiling happening over here in the grid, and you never will. But if you look what happens on the surface of our mesh, you can see that we're getting more tiles inside the same area than we were with a value of 1. With smaller checkers, it's a little bit easier to see and understand precisely what the computer is doing to get the result that we're after. Okay, so there's some areas in here that we definitely need to spend some time working on. I think for the most part, the back is looking pretty good. As I scan over the entire model, what I'm looking for is major warps and major bows in the checker pattern. which is another fantastic reason why to incorporate this checker pattern into your UV mapping pipeline. As you can see from the front, it's very easy to see when we have a problem with our UVs. We're getting some distortions here. The J is being pulled. We're getting some massive distortions on the 4s, and we need to fix that. At the end of the day, we want as close to a perfect grid of checkers inside the texture as we can. There's always going to be distortions. It's impossible to completely eliminate seams and distortions, but we do want to mitigate and reduce their occurrence as much as we can. So let's talk about how the computer is doing this and physically what is responsible. And if you look at the UV down here, okay, you can almost start to see basically what our problem is. And I want to spend some time and really encourage you guys to look at the bottom of my star here. The bottom of my star has some problems as the checker pattern is beginning to bow and warp towards the interior of this little opening here. You can easily see that in the UVs themselves. What we're basically after is a direct representation of this in our UVs of the size, scale, and proportions of their 3D counterparts. So that polygon right there in our 3D view needs to look the same over here in our 2D view. Now, if you look down here at the bottom, that polygon does not look identical to its friend over here in the 3D view. The top is roughly the same, but down here at the bottom, it's way too short. It looks like it's been squished down. So we need to go in and make some changes, some wholesale changes to our UVs. So there's a couple things that we need to suggest and revise as we go through this process. I'm going to turn off the visibility of my checker pattern just for a second to make it a little bit easier for you guys to see the edge selection system that I'm about to go through. When we're working with UVs, we always want to make sure that we select a border. Now, I mentioned earlier that seams are always going to happen. We can't ever get rid of seams. That's part of our business, but we can place them in areas that our audience is not going to see them. So I'm going to select these two edge loops to act as the major seam, and you can see what the computer did. It basically put all of those polygons inside that selection on the back in its own UV island. And if you look carefully, man, this representation of our three-dimensional geometry is spot on. Texture-wise, it's upside down at the moment, so I'll just rotate it 180 degrees. There we go. Texture-wise, yeah, there's no distortion, so this is a perfect UV. We're done with this. But the other side is where we have the most problems. So I'm going to hide that geometry because the back is perfect, and we can start focusing on the front. Now we need to start looking at how we can unwrap our star in a meaningful way to get the results that we're after. And if you look down here, you can see that we have some problems, especially running around the edge loops that make the border of my star. This is a big deal for us, and it's not been UV'd correctly, and it really is probably the biggest area and the biggest cause for this massive distortion down here at the bottom. So we need to look at some strategies on how we can eliminate some of these problems. Earlier, I mentioned that we can't get rid of seams. They're a part of every single thing that we do, but we want to definitely make sure we place them in areas that our audience isn't going to see them. I really, really don't want a seam right here between these two guys and those polygons right there. That's a bad idea. That's a humongously horrible bad idea because that is absolutely a seam, a texture seam that I know my audience is going to see. However, in order to get the wrapping kind of system that I'm after here and the result that I'm after, I want to be able to go in and start to pop off each one of these walls, if you will, into it to make it a little bit more flat. So here's what I'm going to do. I'm going to select these border edges in here. Be careful not to select that front one. I'm going to grab just that side one. Now the computer is going to use that edge as kind of a conceptual little slice. Imagine that you're a surgeon and you're now cutting that part of the mesh. The polygons that aren't cut are going to wrap around the areas that are. So if I have those two selected, these polygons here will start to wrap and bow around that one right there. So think of it like the corner of a box, a cereal box that's all folded down. This is all one piece of cardboard, but we have a seam in our cardboard box upon, at the areas of our selections. And I'm just going to very quickly go through and select the corners. Now, I will get a seam there, but the areas that I haven't selected are going to bend around each other and just give us a really, really nice representation inside of our UV map. I'm really quite pleased with the selection system inside of Modo because I think that really kind of is one of the reasons why the UV mapping toolset in Modo is so strong, that I can very quickly navigate around my mesh and accurately select the areas of my scene that I need to select. I wish it was like this in other applications. It's not. Certain apps make it very difficult to select basic component pieces. In Modo, it's wicked easy. If you start with good selection tools, your life is going to be really, really easy. Okay. It does take some time, so get comfortable selecting things inside of Modo. If you're not, give yourself a good 10 minutes practice. Practice makes perfect, okay? And you'll be able to get through the stage as fast as you can. Okay, a couple more edges to select, and make sure you go through this process with a very high degree of attention here, okay? Because the accuracy of your selections and what you've selected is going to have a direct impact on how the computer interprets your model. Okay, that's pretty good. Now I'm also going to do the same for in here. This is going to give us an interesting opportunity here in a second, one that I'll illustrate once I run UV map again, or unwrap again. FYI, you can run unwrap as many times as you want. It's a non-destructive workflow. You're really not doing anything permanently to your mesh. You're just creating two-dimensional versions. You're just kind of ironing out your mesh into a two-dimensional flat plane. Okay, let's try this. Let's try this again, and we'll see how we go. I'm going to fire off the unwrap tool, left-click and drag, and check that action out. That is precisely what I wanted. Let's turn our texture pattern back on and look at that. Wonderful. If you remember down here at the bottom, earlier it was all bowed and there's some massive distortions. Now we're getting almost a perfect uniform grid across the entirety of our mesh, which is what we're after. Okay, now let's talk about some of these red pieces, because on the surface you think red means stop, red means fire, red means no go, there's a problem. In Modo, whenever you see red, that means you have overlapping UV information. Specifically, we have those polygons, and I'll hit Shift-A, my 3D viewport, to bring me to that area. So I have those polygons there overlapping with these polygons here. Now, some overlap is not a big deal, so you'll want to take a look at this. At times, we can go in and continue to mitigate and work with these overlaps to get the result that we want. But on the surface, this isn't so bad. Some overlapping geometry is just kind of a necessary evil. However, if you want to eliminate all of these overlaps, what you'll need to go in and do is start sewing these verts together. Now, I've selected those two there, and I've selected those two there. It's very difficult to see, and it is very faint, and I apologize. But with those two verts selected, I can go over to my tool options, and under the move and sew command, check it out. I'm going to sew those verts together, which is a fancy word for join. And let's see if it works the first time. We're going to connect to, we're going to average their location, and we're going to move the selected ones only, and boom, there we go. Now we've kind of come up, we've solved one problem, but we have created another. Let me do it one more time for those bottom guys. Here we go. Okay, so now we have to be a little bit more judicious here on our selection, okay? Because I need to move that new pair around to get the result that I'm after, and this takes a little bit of experimentation. One thing that you can do to make it a little bit easier is to change your selection set to element. And when you fire off the move tool, you can click on that edge and notice that my action handles are perfectly oriented to the angle of that edge. And sometimes this is just a good thing to do. Just kind of push and pull it out a little bit and get the angles that you're after. Now, you don't necessarily have to do this, but if you wanted to get unique texture information in that part of the mesh, this is a necessary evil. Any area that's overlapped is going to share texture information. So if you want to have, really unique custom texture information for the corners here, this is something that you'll have to go in and do and basically work your way around the mesh. I mentioned earlier that you can't completely eliminate distortions. You can just reduce their apparent nature inside of our 3D apps. And this is a universal idea. This isn't something or a problem that's unique to just working inside of Modo. It's kind of one of the grand problems and challenges for all UV artists is reducing these distortions as much as you can. So now we're on our way. And you can almost immediately see inside of our 3D viewport why having some of these elements connected to each other is such an important idea. Look at B08 here inside right there inside my screen. From the front, it looks pretty fantastic. And then the texture is bent and warped and wrapped around that corner, which is actually kind of what I'm after in this particular situation. I don't want to have a very noticeable seam, as you can see down here inside of my grid. In certain use cases, that seam is going to be noticeable, and it's not going to give me the result that I'm after. Okay, this is looking pretty fantastic. I'm very pleased with the results that I've gotten here. I could go in and completely break all and sew all these pieces apart. That's definitely inside of what's possible for me to do. Let's look at the interior here. Down here at the bottom, we have a lot of overlapping geometry, but now I have to ask myself, does it really matter that I have overlapping UVs in this part of my mesh? And for me, I'm going to say no, it doesn't really matter, and here's why. If you look back at how the end result of my product is going to look like, let me unhide the rest of my geometry here. I'm going to hit there we go. And if we look at the bottom, check it out. I'm going to have a lock in there, so I really don't necessarily care about the inside of my little star shape there. It's not important for me, okay? And I can move on and continue working without having to worry about the texture information on that part of the model. Now, be careful. Go through this. Be as careful as you can, okay? But don't spend time on areas that are not going to get a direct benefit. Okay, so let's talk about some of the other tools inside of Modo that will help you get to the end result fast with our UVs, because the unwrap tool is quite magical, but I also want to show you one other one. I'm going to work on the bottom just really quickly here. Here's the front, and as you can see, I've gone in and I've kind of modeled some, the illusion of some boards in here. I don't necessarily care so much about any sort of texture stretching or distortions inside the board. It's such a small area inside the scene that I'm confident that my audience is never going to see it. I just want it to collect some light, so I don't necessarily care about the texture information. One of the other great tools that we have at our disposal is called Project from View. And Project from View can be found here in our UV mapping toolbar. And Project from View requires a polygonal selection this time. And once you've activated the tool, you have to click inside of your Perspective OpenGL viewport. And as you can see, it basically took a snapshot of those polygons and it made UVs for them. However, if we go back, I want to turn on my checker pattern again and ensure that the texture locator is on, which one is it? I've already forgotten, I apologize. Let me go back to my lists. It is on top UVs for the bottom one. And let's just make sure that's all set. Top UVs, there we go. So now it's looking at the right. Now it's looking at the correct UV map and the correct UVs. Look what we're doing here. If you notice that the distribution of checkers on the pattern itself are much tighter over here than they are over here, and everything looks like it's being pulled and stretched into the upper right-hand corner. That is wholly responsible or wholly due to the fact that our UVs have this massive distortion. Because we were at a really odd angle like this when we initially did the Project from View operation, my UVs were captured in the same orientation as my 3D scene. So let me do it one more time. I'll make it a really extreme example. Project from View, I'll click, and you can see that the UVs that were created, just a snapshot of the selected polygons, and wow, massive distortions. So here's the keyboard shortcut, the trick, if you will. You can still work inside of the Perspective viewport, but hold Control, Shift, A, and it's automatically going to align the Perspective viewport to look directly, or dead on, if you will, at the selected geometry. Now you can simply fire off the Project from View tool, bloop, and we're on our way. Things are good. I'm happy with the projection, and I'm on my way. So this stuff in here can cause a little bit of problems, but like I said, I'm almost 100% sure my audience isn't going to see that, and I'm not going to spend my production time really focusing on that stuff as well. Okay, let's talk about cylinders here for a minute. Cylinders are kind of fun, and so let's get to work on these guys as well. Okay. So the way we unwrap and the way we work with cylinders is a little bit different, okay? For flat planar things like the wood and the top, that'll take care of itself. But for something like a cylindrical object, we have to look at the strategy a little bit differently, because what we're trying to not do is get something that looks like this, right? We don't want UVs that look like that, because that's always going to look good from the front, but then once we go to the side, ooh, look how much it's stretching there, and then it looks good over there. So this is not really too hot, and there's a significant stretch up here at the top. So we're not looking for flat surfaces like this. We're looking for little grids, and let me show you what they look like. We can easily create this with the Unwrap tool, and I'm going to select. Let's turn off the image so you can see what's going on. I'm going to select the cap. Now, because I selected the entire edge loop, all of these polygons in here are going to be placed on their own separate UV island. You'll see that here in a minute. And this is going to be a symmetrical piece for the most part. So I'll do both sides with the same edge loop. Now what we need to do is that we need to select a spine, if you will. We need to select one of these edge loops that runs the full length of the cylinder. I'm simply going to double click on one. Now I only want one side. Notice that when I double clicked, it selected both the top side and the bottom side of that edge loop. So now I got to go in and just deselect some of these things real fast. Luckily for us, our Moto selection engine is quite good. I'm going to make some quick selections here. Maybe use my lasso to speed this up a little bit here. Holding down the control key will allow you to very quickly deselect components from your selection. Almost done. Right-click marquee selection box while holding down control will allow me to do a number of them at a time. If you hold down the middle mouse button while you hold down the control key and click out a drag out a box, it will allow you to select through your mesh and grab the ones that are facing behind you as well. Almost done. A couple more. There it is. Okay, so if you look at what I have selected, that's my fault. I may have accidentally deselected these guys in here. The more energy and attention you place on your selections, the less you'll have to UV map. And that, I think, is good. Let's just do a quick visual double check. Yep, okay, good. I'm very pleased with that. Let's run the unwrap tool now and see what we get. And this is what we're after. Now, don't freak out. Don't freak out and don't drop the tool. Let's look at precisely what the computer is doing here. The areas that I had selected are the areas where the edge loop went all the way around the mesh. Look at what it did. It placed them all on their own UV island, and they're looking pretty much perfect, okay? However, the areas in between, we need some love in here, okay? Let's turn on my texture. And you can see that in certain areas it's looking really, really bad. In other areas it's looking pretty good. So let's look at some ways that we can go in and continue to refine this. Specifically, we're going to need to orient this piece a little bit because it's just kind of all over the place. We have some lovely orientation tools, so we'll do orient pieces. Let's just try horizontal. Yeah, and it did a pretty good job of trying to flatten out and place that precisely where it is. Now, what we're after here is a uniform grid of textures, or excuse me, a uniform grid of checkers across the entire texture. See how on the actual texture itself, we're getting big checkers there, and then teeny tiny checkers down there. That's not what we're after. We want a consistent level of quality across the entire piece. So we're going to have to go in and make some changes to this. So there are a number of really great UV editing tools that will allow us to spread apart our UVs and get a more predictable and a more uniform result across the entire UV. The one that I would like to try first is called UV Relax. It's a great one. Now, UV Relax works off some tools down here. So we have a couple modes, and like UV and like the unwrap tool, we also have an iterations value, which will turn. Which will basically allow us to reapply the algorithm over and over and over and over again. FYI, before you go any further, I would recommend that you save your project file right now. I've noticed that the UV Relax tool, because of its algorithmic weight, if you will, tends to crash Moto more often than other tools. So out of habit, I always save before I start left-clicking and dragging. And as you can see, as I left-click and dragged, I ironed out that entire area. And while it's not perfect, it is definitely a whole lot better. One other option that I want to show you, I'm going to go back in time a couple steps here, is UV symmetry. Just make sure this is on one of the axes. I think for me, I'm going to have UV symmetry on, let's try that on the U. Yeah, that's pretty good. And yeah, I'm liking this. This is a step in the right direction. Again, it's not perfect, but it definitely is in a much stronger result than it was a minute ago. Now, the big problem that we have in our mesh right now is that all the horizontal spans in here, they are kind of bowed and they're kind of warping the texture all over the place. So let's make some changes to that. And it's really easy for us to make some changes. I'm going to initially start off by selecting this top horizontal span. The up arrow is your friend here. Oh, and it's doing something all over the place. Let's turn off my my symmetry here. There we go. There we go. That's what I'm after. Then hitting the up arrow will allow you to very quickly go through and just select that border. You can also do it in the 3D view. Either way will work. There we go. And I want to start flattening all these out by hand, and it's super easy to do that. That's what these arrows are going to do inside of our UV tool set. They're going to look at the current height of this entire edge selection, and specifically, it's going to look at the height of all of the verts along this edge selection, and it's going to move either up, down, left, and right all of those verts to the position of the vert that is at the highest value. I think I misspoke. Let me try that again. I want to move all these up, so it's going to analyze this edge selection. It's going to find the topmost vert and move all the other verts to it. Now, if you look way down over here, that looks to be the topmost vert. So if I hit the up arrow, boop, they all move up over there. And if we just go down the line here, moving all of them up, we'll get a much more uniform grid of UVs. Now, the bottom one it's going to require a little bit more love, just a very careful selection. You can't double click on it because it gets the entire border. If you look at the result over here inside of our UV window, again, not perfect, but we are getting better. And the last one, bloop, fixed all that problems at the seam. Wonderful. Now, you can also do the the vertical ones, all these guys as well. I would encourage you, but just make sure that you're doing it symmetrically. If you look at these polygons right here, that's the dead center of our mesh, okay? So you want to work from the center, okay? And then you got to pick a direction. In my case, I'm going to move everything to the left. So we'll hit the left arrow, and now all of these are going to be the left arrow, right? Now, trust me, it's going to start you'll get some overlap every once in a while, but as you work down, all of those problems will iron out if you're just disciplined, and they all go to the left. And then on the opposite side of the center point, we'll move all of these vertical edge spans to the right. And if you're disciplined, all of the sizes of our polygons will remain the same. And what we'll get is a much, much more uniform representation of our texture inside of our model. So we've got some overlap here. Don't freak out, because the next one will fix it. Boop, there we go. And we'll get some overlap in here, but that's okay. We'll get there. Slowly but surely, we'll get there. So this one in here, we'll just be very careful with the up arrow to select all the way down, align it to the left, and there it is. Now, I'm not going to do the other side because, I know from my own personal experience, this is like watching paint dry. But now, if you look at the way the texture is being wrapped onto this area, almost all of our grid squares are nice and uniform, and that's exactly what we want. In comparison to these over here, not so hot. There's some wacky distortions. Look at all these. Look at the grid of the textures, the checker on the texture now. Everything is kind of warped and slanted to the right. That's not what we want. If I could very quickly go in and start aligning these things, we can fix those problems easily. Okay. UV mapping is a fun process, but it does take some time, and it definitely takes some labor. It's not exactly the most stimulating thing, but the payoff is absolutely worth it, because now I can very quickly and very accurately go back in and place texture information precisely where I want it inside of my mesh. I don't have to worry about any sort of tearing, and I'm in control over all of the warps and all of the distortions inside of a piece of 3D geometry. It takes a little bit of love, but you only have to do it once, and then the payoff is being able to just go in and paint on your model, and everything is just going to look amazing. It's well worth it, in my opinion. I've gotten to the point now, and because of how strong the selection in the UV mapping tools are inside of Modo, I UV map everything. There was a time in my life where nothing was UV mapped, and I relied exclusively on the projection system inside of any number of apps to give me that final result. Now, because of the power and the strength of the UV mapping tools inside of Modo, everything gets a UV map. In the feature film world, you don't necessarily have to have UV maps, but as we incorporate more real-time assets, everything has to have a UV map. So this is a critical part of our workflow. Think of the strategy. Think about where you want to put your edge seams. Think about the size of your UV maps in relationship to each other, and use the tools to help you craft very high-quality, distortion-free UV maps for all of your models. As always, if you have any questions, you know where to find me. I'll be more than happy to answer questions in the forums and look at your UVs and make suggestions and help you guys go through this process. Thanks a lot, everyone, and I look forward to seeing you in the forums.